Hi, in this Let's Create series we're creating a simple reaction game like this. A circle will appear randomly on the screen and you have to tap it as quickly as possible. For your score we discard the fastest and slowest reaction and average the time taken for the others. Let's get started. For this project I'm using the universal 2D template. Okay, the first thing we want to do is create our target. For this I'm just going to use a simple circle sprite. Right click, 2D objects, sprite, circle. We'll just call that target. In order for this to be clickable, we'll need to add a circle collider 2D to it. We should also update the colour of this to be something a bit more exciting. I've chosen green. We don't want the target to show straight away, so we'll simply disable the game object. To our target, we'll add a new script, simply called target. We'll get to that script in a minute. First, let's create our GameManager and base logic. Create a new empty game object, which we'll call GameManager. I've just reset the transform so it's centered. To that, we'll add a script called GameManager. I'll just quickly create a scripts directory and drag them both in there to keep things tidy. Final thing in our setup is to create a play button. Right click, UI, button-TextMesh Pro. If this is the first TextMesh Pro you've imported, you'll get the Importer dialog pop up. We just want to import the TMP Essentials. You can see the button is tiny in our bottom left. This is because my game window is in 4K, so our pixels are small on the screen. As you'll want this to look the same in any resolution, click on the canvas, and in the canvas scaler we can change the UI scale mode to scale with screen size. Now if we just go back onto our button, we can use the anchoring widget. Holding down Alt, we set the position and the anchor, and we can anchor it to the bottom middle. There it is, a much better size. Let's just move it up a bit off the bottom. If we open our button, we can change the text to play, and whilst I'll rename it play button. Okay, now we're ready to dive into the code. We'll start with the GameManager.cs script. Okay, within the code, I just want to talk about the using statements first. The version of Visual Studio I'm using with Unity automatically adds these in when I use the relevant bits in the code. However, you may be using some other editor, so I'll just go through them now. The first is systems.collections. We need this for the IEnumerator type we use for coroutines. The second is system.collections.generic. We need this for the list type. Thirdly, we have system.linQ. This provides some nice methods for working with lists, such as min and max, so we don't have to write our own. Finally, using Unity Engine to give us access to all the Unity related bits. Now, in our Game Manager, there's a few things we need access to. The first are the round attributes. These will define the main properties of the game. For this, we've got an int numRounds, I'll set to 5, then two floats, delay lower bound and delay upper bound, which are set to 1 and 5 respectively. These are all serialized fields so you can change them in the Unity inspector. The numRounds is how many targets we'll have to click before we calculate your reaction time. To this, we'll add a min3 header. This means the inspector will limit the lower bound for this. We chose 3 as our lower bound because to calculate your average reaction time, we discard the slowest and the fastest and average the rest. That's the sort of thing they do in a Rubik's Cube competition, so I thought it'd be good to include here. As such, if we're discarding 2 entries, then we need at least 3. The lower and upper bounds for the delay is how long we're going to wait between pressing one target and the next showing. We're going to choose a random time between these, so you can't guess when it'll appear and try to tap in advance. Next up, we'll need a reference to some game elements, so we'll put them under another header. These are going to be 2 serialized private game objects, one for the target, as we'll need to control the visibility of that, and another for the play button, as we'll want to hide that when playing the game. We will also need 2 private variables to track game state. The first is a double we'll call showtime. This will track when the target appeared, so we can calculate the reaction time. The second is a list of type double called reaction times. which will instantiate with new. This will hold each of the user's reaction times in the game, which will store so we can calculate the average later. So the first new method to create is a public void start game. This is public as this is what we're going to call from clicking the play button. This is very simple. It'll just do three things. Firstly, it'll hide the UI. At the moment, that's just the play button, which we can hide by calling setActive and passing in false. Then we'll clear out the game state. If you're playing again, we always want to start from a clean state, so call reactionTimes.clear. Finally, we'll start off the game logic to show the targets. As this will be time-based, we'll do this in a coroutine so we can add delays into the code path. So create a new private IEnumerator called playRound, and we can then call this from our start game method using start coroutine and passing in our new coroutine playRound. Our core game logic coroutine doesn't have to do much. The first thing is to wait for a random amount of time before showing the target. We'll calculate how long to wait in a float delay variable. This will be set using random.range between our delay lower bound and delay upper bound. So if you're using the defaults, between 1 and 5 seconds. To make the code wait, we yield return a new wait for seconds object passing in delay. This coroutine will then wait for the delay before carrying on with the code. After that delay, we want to record the time the code executes, as this is when the target will be displaying and the amount of time that passes will indicate your reaction time. So in our global variable we created earlier, showTime, we'll set it to time.unscaledTime as double. We're using doubles rather than floats for greater precision. The unscaled version means that if you alter the timescale, then it still records real time, so nobody can try and cheat by slowing down your game. Now we've recorded the time, we'll display the target. Firstly, we set the position using target.transform.position to random.insideUnitCircle times 3. Random.insideUnitCircle is a cool helper function in the random package that can be very useful in Unity games. It'll be a random point in a 2D space within the unit circle, which has radius 1. 1 is probably a bit small given the standard orthographic projection in Unity is set to 5, so multiplying it up by 3 means the target will be placed in a bit more of the screen. Finally, we can use the setActive on the target, passing in true, to display it. That is all the code we need to display the target, but we also need to handle clicking of the target. For this, we'll create a new method which will be public called targetHit. This needs to be public as we want to call it from within the target object. The first thing to do is record the user's reaction time. We do this by using add to append a new element to our reaction times list. The time we want to add is the current time, which we get with time.unscaledTime as double again, and subtract showTime, i.e. how long has elapsed since the target was shown. We can then hide the target using setActive passing in false. At this point, the target will have disappeared. We need to know if we'll show it again for the next round. We have our variable numRounds, which tells us how many rounds we have, so we just need to compare. If reactionTimes.count is less than numRounds. If it is less, then we still need more observations, so we call the playRound coroutine again with start coroutine. That'll kick off the cycle again. Else, we're finished and we want to calculate the reaction time. As I've said to calculate the average, which will be a double as that's what our times are, we want to take first the sum of all our reaction times, which we can use .sum to get this on the list. This is where linQ is coming in. Then we want to discard the largest and the smallest. To do this, we can simply subtract reactionTimes.min and reactionTimes.max, again using those helpful linQ functions. There are only 5 elements in the list, so we don't need to worry that we've actually iterated through the list 3 times when we could have done it in 1. In doing that, we've got the sum of the middle 3 elements. To get the average, we then just need to divide this by numRounds minus 2, as that's how many elements we're averaging over. That's given the average as a double. For displaying this, we probably want to report in milliseconds. So we create an int milliseconds, which will be average times 1000 and cast it to an int. We don't care for fractions of a millisecond here. There's two things left to do. Firstly, we can show our UI again, which is just our play button at the moment with set active. Then we can show the score. We haven't created any UI for the score yet, so let's just put it into the console. Firstly, we'll iterate over each time using a for each loop. This sets the double reaction time to be each element of the reaction times in turn. Given the reaction time, we can simply log it out with debug.log. This will give us a record of the time so we can check it's working. Then finally, we should also show our average score with another debug.log statement. This time I'll format it a bit. This will be the score, then the time in milliseconds. The dollar before the string tells C# it's a formatted string. Any variables in curly brackets are rendered as strings for you. Later, we'll actually display this in the UI. Okay, back in Unity now, we can connect up our GameManager and test out the basic functionality. On the GameManager object, drag on the target and play button game objects. Then, in our play button, we can add a new on-click event using the plus. To this, we'll drag on the GameManager object and select the start game method we wrote. Let's hit play and check this out. After a short delay, the target appears randomly within the center of the screen, this time at the bottom. Clicking doesn't do anything as we haven't written the target script yet. Let's just start again and check it is indeed appearing in a different place. Yes, that all looks good. More off to the left this side. Now let's jump into the target.cs script and get the on-click handling set up. The target script is going to be super trivial as we're handling all the game logic within the GameManager. So all we need to do is get a reference to the GameManager. We'll reference this by the inspector, so create a serialized field, private GameManager called GameManager. Then we'll add the onMouseDown method. This will get called when our target is clicked, and we added the collider so it will pick up the clicks. In this instance, we simply call GameManager.targetHit. That's it. When the target is hit, we just tell the GameManager and let it deal with any logic we want to perform. We've already written that logic in the GameManager, so that should be enough. Let's head back into Unity and check this out. On the target game object, the first thing we need to do is drag in the reference to the GameManager, then hit play and let's check this out. We'll start the game. This time when we click, target it should disappear. Then a few seconds later, with some random change so you can't predict it, it appears and you can click again. After we've gone through all the rounds, 5 in this case, you can see that the play menu comes back, and in the console, we can see our 5 raw timings and the score printed beneath that. 520 milliseconds, not exactly great. Let's hit play and make sure everything resets so you can go again. I'm trying much harder this time, but I keep missing the targets. Less a test of my reactions, more of my mouse accuracy. That's all working great. Second time, 5 new timings and a new score. This is such a simple concept, we're essentially done. So let's spend a little time polishing this. Everything is better with particles, so let's start there. When we click a target, let's make it a bit more reactive by having a burst of particles. Right click, Effects, Particle System. We'll call this Explosion. There is a second pause between rounds of our game. As such, we want the particles to last no more than this. So change the duration from 5 to 1. We'll want the particles to have a bit of variation, not all acting the same. Firstly, we'll change the start lifetime. I like to use random between 2 constants for most variations. Let's start with between 0.25 and 0.5, so all the particles will have disappeared before our 1 second duration. At the moment, they're continuously emitting. If we go down to the emissions section, we can see that they're set at a rate over time of 10. Let's set this to 0 and instead add a burst by clicking on the plus icon. Here you can set at what time these happen, how many there are, how often they happen, and so on. We just want a single burst, so leave everything alone, but bump the count to 200 so we have lots. Because we have a white square material on there, it doesn't look very impressive, just a big blob. We'll change that soon, but let's get it emitting in the right direction. In the Shape tab, we can change it from a cone to something better. In this case, I think the best one will be a sphere. Here the particles are emitted from the surface of a sphere, so you can get them going in all directions, which is good for an explosion. However, the default size of this is far too big. We really want them exploding from a point, so let's set the radius much smaller at, say, 0.1. That looks much better. Now let's make something a bit prettier that fits with the game. As the target is a circle, then I thought circular particles would be best. Rather than plain circles, I've gone with a ring instead. You can find this image linked in the description, or you can add your own. So drag this into your assets to import it. Then we can right click, create material. We'll call this ring to match our texture name. And this defaults to a URP 2D sprite lit default. But we don't care about lighting. Using the drop down at the top, we can change this to unlit version in the universal render pipeline 2D sprite unlit default. This only has the sprite texture, and we can drag our ring onto there. Now if we go back to our explosion and navigate to the render tab at the bottom, you can see it has the spritelit default material. We can drag on our new ring material instead. And now we've got an explosion of rings instead. Now for the final bits of variation in the effect. Back at the top, we'll change the start speed to again be a random between two constants. I've chosen between 2 and 4, which gives you a variation in speed. They're far too big, so change the start size to between 0.1 and 0.2. That's looking good, but they disappear a bit suddenly. It'd be better if they fade out. There are two ways people normally do this: shrink the particles to make them disappear, or fade them out. We'll choose fading them out by adding a color over lifetime property. Enable it by checking on the tab. Then in the color picker, the top is the alpha, so we set the endpoint to be transparent. Then we can set the starting color to a green to match our target. You'll see they actually go green to white whilst fading out because the color gradient is doing that. We can just drag off the second point to make it a solid color rather than a gradient. That's looking okay for now. You can of course tweak and modify this as much as you like. I wanted to keep it subtle because the focus of the game is the reaction, not the effects. The final thing to do is stop it looping. An explosion normally only happens once, but it's good to keep on whilst you're tweaking the system. At the top, you can just uncheck looping. If we switch back into the scene view now, we can use the particles widget to play this whenever we want to see it again. Jumping back into the tile script, let's make it so this is shown when you click on the target. The first thing we want to do is get a reference to the particle effect, so add another serialized field of type particle system called explosion effect. Then in our onMouseDown method, we can start the particle effect. We need to move the particle effect to the position of the target, so set the explosion effect.transform.position to the position of the object this script is attached to, i.e. the target. Then we can simply call the play method on the explosion effect particle system. Note that it's important to do this before you call the target hit method on the GameManager, because that will deactivate the target and stop any further code executing. We're not instantiating the particle effect a bunch of times and destroying it. There will only ever be one target, so we can keep reusing the same one and showing it. Back in Unity, we can go to our target object. You can see the new explosion effect in the inspector. Just drag on the explosion object with the particle system on it into that space. Hit play and let's try this out. You'll notice that when the game started, the explosion played, even though we didn't click on anything. So stop the game mode. On the explosion particle system, you'll see there's a setting called Play on Awake that is on by default. We do not wish for this, so you can uncheck that. Now when we start the game, it starts without the effect playing, excellent. Start the game by hitting play. After we click on our first target, you can see that the effect is shown. And for each of the subsequent targets that I'm clicking on, the effect is correctly showing in the right place at the right time. Excellent, all working as intended. If only my reactions were a bit quicker. 733 milliseconds, that's terrible. Rather than let feature creep get away with me, we'll do text for just the latest score. I'll leave tracking a high score as an extension that you can add on. So right click, UI, text to add a new text element. Again, I'm in game mode so I can see it easily. We'll anchor this to the top, and as usual, hold Alt to set the position at the same time. We want to bring it down from the top a bit, something like -75 looks good to me. Center the text using the alignment widget. The text will be something like "great score" with the time in milliseconds. You can see that by default this will wrap the text as the object isn't big enough. Let's just up the width to 500 so it's plenty big enough. I'll remove the text now we're happy, as when we start we don't want it to show any score. Finally, we can rename the object scoreText so we can remember what it's for. Back in GameManager.cs script for one final time, we need to add one more object in our game elements. We'll add it of type tmpro.textmeshPro.u.GUI so we can access the text element easily and call this scoreText. In the start game method, when we're hiding the UI elements, we also hide this. So add scoreText.gameObject.setActive false. As we've got the text element, we need the GameObject bit there to access that to deactivate it. Down in the targetHit method, in the else branch, we'll show the score text. Here we want to update the score text, then activate the object. Rather than just showing the score as say 350 milliseconds, it'd be nice to be a bit more dynamic. So let's add a qualifier to this. We'll set this in a string called score type. If the milliseconds is less than 200, we'll call this epic. If it's less than 500, it'll be average, else it's rubbish. I've just added 3 to keep the code short here. Feel free to add as many as you like. Now we've got the qualifier, we can set the scoreText.text to this. We'll use the $string again so we can put in our variables directly. First, we'll have the score type in there, then the word score, followed by the milliseconds, and we'll suffix this with ms to make it obvious it's milliseconds. Now we've updated the text, we can set the scoreText game object to active. That's it. Let's jump back into Unity. On our Game Manager, we just need to drag on our scoreText object. Then hitting play, we can check this works. I'll play through the game and see how well I can do. That's great. At the end, the score is displayed for us. 431 milliseconds. Very average. Hitting play again, and the high score is hidden, and you can play again. As with all the Let's Create series, I've helped you create the core game mechanic, and I leave it to you to build on this. Some possible ideas for you. You could create different difficulties, make the target smaller and perhaps increase the size of where it can go on the screen for the harder difficulties. Persist the high score as well as showing the latest score. You could also add sound to the target hit. That's it for this video. I hope you found it useful in some way. As ever, the full code is on GitHub and linked in the description below. See you next time.